Okay, so that's the tube we're going to bend?
That's the tube we're going to bend.
And is this the print right here on the top?
That's the print on the top.
Sorry. Just 028 83 85 00. All right. So you're starting with a blank template?
No. What we're doing is I'm showing you what we've already programmed in here.
Okay. Oh, that's from the bad supervision file, right?
No. This is directly from the print.
Oh.
But what I did is I actually programmed this in the offline programming version of the Bender software.
Okay.
So I originally programmed it using the FPB screen, putting in the last length, start length, total length from the print, and letting Nick calculate a bend start position. And then I entered the LRA data.
Okay.
And but that was because your print is in inches.
Yeah.
And STEM software only accepts millimeters.
Oh, okay.
So this allowed me to program it in inches and then switch it to millimeters and then send it to or import it into the
SIM
SIM software. And I did
now,
that.
Someone that doesn't have access to the Bender, will they still be able to do that on a PC that's not the Bender?
If they have, well, I did it on a PC. I did it on offline programming software. Identical to the Bender interface.
Okay, so the offline programming is a separate software than the SIM software.
Yes.
Okay.
Yeah.
All right.
However, I didn't have to do that. I could have just translated your length values from inches to millimeter on the print and done it manually there.
Now, once you do it here, can you then take that information and stick it over here?
You sure can.
Okay.
All right. Okay. So what I've got over here, I've got the part programmed. I've also selected a machine, KB10, and this particular model tells me that I've selected a machine with extended chuck, which matches what you guys are using for chuck jaws.
Oh, okay.
I've also got a tool set selected that matches the 3/8 75 CLR tool set.
Okay.
The only thing it may not match is the length of your pressure die and the reach of your pressure and clamp dies, but that's something we can get when we measure your tools.
Okay.
So we've created a part, we got a 3D view of it.
All right, that looks good.
So you can see how that 3D view will help you out figuring out whether you put the rotation value in right.
Right, yeah.
So there you go. You didn't have to scrap a part to figure that one out. All right. Now, I can run it. And when I go to run it, I'll get a couple of messages.
Okay.
Normally, I'll always get one message.
Okay.
And this message tells last leg too short. What that says is I cannot hold on to that leg with the chuck while I'm making the bend.
Okay.
I have to back out.
Okay.
So, if that's okay, and
so we'll move from Japanese to German.
Yes. So if I want to ignore that, in other words, I'm letting go and getting out of the way.
Yeah, you do.
I'm jaw. All right.
German software.
Okay, so here's a model of the Bender.
Ah, okay.
With,
Oop, don't get too close.
Extended chuck jaws, extended tube stop, so it should be set up identical to your Bender.
Okay.
And then we just run it.
Okay. Cool.
We'll run that again, this time a little slower speed.
Man, this is going to make our Bender really fast.
If there was a collision, it would ask me to get the solution and would try to run the part again with one of the avoidance moves.
Yeah.
And it would keep doing that until it got it off the Bender. And then it would ask you to write that to the program.
Okay.
Do you want to modify the part so you can see a collision?
Sure.
Yeah.
Did it? I guess since you did the program first, you decided when you were programming which end to start the bend, which I understand on that tube is kind of obvious where you want to start. You don't want to end up with the short end with nothing to grab onto with the chuck.
Yeah, and one of the other reasons is the 180-degree bend as the first bend requires a special move, takes a little cycle time. I make it as the last bend,
okay,
and I don't have any issues.
All right.
All right, I changed something. It may or may not cause a collision with this part. I just changed the rotation direction. I don't think it's going to cause a collision. No, it didn't. Like I said, it's too simple a part. Well, why don't we just do this? We'll change the direction of the part and try to do 180 first, and then it's going to choke and try to reverse the direction.
Right there.
Yeah.
Okay.
It's going to keep trying all of its solutions, and then it's going to reverse the direction and run the other way.
Okay. Oh, that's pretty clever.
That's very good for the simulation software.
Assign bending list. Yeah. Okay. Now just rewrote the program to run it in the opposite direction.
Okay.
Even though my option is still set to last. Just rewrote all the bending data to move it first.
Now, if you're going to... Okay. So, you don't want to program from this?
Oh yeah.
You can program
Unless you want to do it from in millimeters.
You want to do it from here.
Yeah, I mean...
You want to program from here.
The only reason, I
but-
programmed from there was this change from inch to millimeter, and that's just because I didn't want to say we're a calculator and convert the inch values to millimeter.
You would think from a programming standpoint that that would be a really easy capability to add to have it be able to handle inches, or at least it can handle millimeters internally, but display inches as an option.
Those are things that when we would request that, it will get an upgrade, and you'll get an upgrade, and that's
In fact, that's the way your bender works. Your bender runs in millimeters, but the graphic panel software converts it to inches.
Right.
You select inches.
Yeah, but you don't have to convert it ahead of time before you start punching in the numbers.
You work an inch or metric, but the graphic panel is what converts it.
Right.
The bender stores everything metric.
that's something that we need to talk.
Okay, well I like that. Now, do you have the offline programming software on here too?
I don't know if I do. I don't have the key plugged in, so I know I can't run it.
Okay.
I can bring my laptop. I have it there.
Mine's powered up and it's got the key plugged in.
Okay, so this is the offline programming software.
I also give you a little example of the remarks. And
Oh yeah.
that's normally what I like to put in the remarks. Other people will use them for whatever, but
Yeah, there's a special note that you need to use, making sure the operator knows when he runs that part.
Mm-hmm.
You can put it there.
and to me that just identifies the diameter tube and the tool set.
Well, would you mind programming this from scratch so I can see what the process looks like?
Sure. Let's get this part. Let's make sure
I'm actually thinking though it might be easier to just have a calculator and convert to millimeters. Good thing metric didn't change the degrees. Which technically they should, since 360 degrees in a circle doesn't make much sense.
I'll be honest, yeah, it probably would make more sense to do that. Just because that takes the transfer process away.
Right.
But if I was going to do that, we would go Others, New, File Name. Let's just go 8385 because we're going to delete it. And then I say no if I'm going to create it from scratch.
Okay.
And here's where I put in measurements, and I know it was
Isn't this it here?
1905, and I added 5 millimeters, so it's going to be
So this is the one he's entering now instead of the post to the.
Oh, the tooling. Okay, yeah, I should have known that.
24.05, because I'm counting for not only the diameter or the radius of the bend die, but the interlock. Interlock. See, this bend die is 3/4 diameter, but you got another 1/4 inch of interlock.